Hello, this is John from Military Systems Explained, and today's topic is the M109 155mm self-propelled howitzer, a system that has been modernized repeatedly while keeping the same core idea for decades. That idea was simple but demanding. Place heavy 155mm artillery on a tracked armored platform. That could keep pace with maneuver forces. Halt. Deliver accurate fire, and then relocate before enemy counterfire could respond. The M109 family entered service in the early 1960s and has remained in use through multiple major upgrades, including the Paladin line and later modernized variants, while preserving its original role within artillery units and adapting to changes in doctrine and technology over time. The problem it was built to solve was not just increasing firepower. It was mobility, survivability, and operational tempo. Towed artillery could deliver effective fire, but it struggled to move rapidly with armored formations, reposition under pressure, and protect crews and equipment during movement across varied terrain. Earlier self-propelled artillery systems existed, but the Army required a standardized, fully turreted 155mm platform, capable of sustained operations alongside mechanized forces. Equally important was long-term growth potential. The system needed sufficient space, power generation, and structural margins to accept future improvements in guns, fire control, communications, and automotive components. These requirements shaped the M109, not as a single finished design, but as a platform intended to evolve and remain relevant over decades of service. When the M109 program was defined, the central challenge was not novelty, but coherence. Artillery planners were trying to integrate heavy indirect fire into formations that were becoming faster, more mechanized, and increasingly dependent on coordination rather than static positions. The requirement therefore centered on creating a system that could operate continuously as part of a maneuver force, rather than as a separate, slower element brought forward only when conditions allowed. This imposed several layered constraints. The vehicle had to provide basic armored protection for the crew, while remaining mechanically reliable over long movements and repeated firing cycles. It also needed to support sustained operations without excessive logistical burden, which meant avoiding overly complex or fragile solutions. Just as important was the requirement for institutional longevity. The system was expected to remain viable as communications methods, fire control processes, and artillery employment concepts evolved. Instead of defining a fixed end state, the requirement implicitly called for a platform that could absorb change over time. The design process followed these priorities closely. Rather than pursuing a radical configuration, engineers selected a conventional tracked chassis, combined with a fully enclosed rotating turret, separating mobility and firing functions in a way that was well understood and easier to refine. This choice reduced development risk and allowed the artillery system to be upgraded independently of the automotive base. From an engineering perspective, the emphasis was on space, accessibility, and structural margin. Internal volume and layout were treated as strategic assets, enabling later integration of new fire control equipment, communication systems, and revised gun assemblies, without forcing a complete redesign. Manufacturing and maintenance considerations were also central, as the system needed to be produced and sustained at scale. This deliberately conservative design philosophy explains why the M109 did not become obsolete after its initial fielding. Instead, the platform's architecture allowed successive generations to be modernized incrementally, extending its service life far beyond what a more tightly optimized, but inflexible design would have permitted. The M109's transition into production followed a staged ramp-up with clearly documented milestones. In October 1961, the United States Army issued a production order to the Cadillac Motorcar Division of General Motors, with manufacturing at the Cleveland Army Tank Plant. The first production vehicles were completed in October 1962, and in January 1963, the Army authorized an extension to continue the limited production classification. First issues to Army units began in June 1963, and the system was standardized as the M109 in July 1963. By December 1963, the contract for the third year of production was awarded to Chrysler, while production remained centered at Cleveland. A later Government Accountability Office review also frames the system's broader timeline. The M109 was developed in the late 1950s and fielded in 1963, reinforcing that the early production push was tightly tied to getting an operational capability into units, rather than waiting for a perfect final configuration. The Government Accountability Office report is explicit about what the Army considered deficient in the baseline system: responsiveness, survivability, lethality, and reliability, availability, and maintainability. On responsiveness, it notes slow, error-prone procedures, such as orienting guns using an aiming circle, establishing and maintaining wire communications with the Fire Direction Center, and exchanging fire missions and status information by voice with manual methods, all vulnerable to terrain, visibility, and hazardous conditions. On survivability, the report highlights a concrete issue. For tasks like aiming circle alignment or laying communication wire, crew members had to exit the vehicle, increasing exposure to threats including contamination hazards and small arms. It also notes that dispersion and separation between guns could be constrained by line-of-sight needs and wire communications limits. For reliability, availability, and maintainability, the report ties low operational availability to poor armament reliability, high maintenance ratios, and the fact that many maintenance activities had to be performed at rear locations, reducing readiness. After being fielded in 1963, the M109 began moving from new equipment into routine unit service, and its first large-scale operational exposure came soon after. A widely cited program history notes the system's combat debut in Vietnam, with around 200 vehicles deployed in 1966, followed by serious fleet-wide mechanical issues that were difficult to fix in theater, leading to a temporary withdrawal and a subsequent upgrade path. That pattern fits what you already have from the Government Accountability Office. Early fielding happened first, and major improvements followed, as deficiencies were identified in real use. In the early 1960s, the United States Army reorganized its divisions around a structure designed to keep pace with fast mechanized maneuver. That shift mattered for artillery because it pushed divisional artillery units towards self-propelled systems that could move, disperse, and support armored and mechanized formations without slowing them down. In the Army's own organizational history, armored and mechanized divisions are described with artillery, built around self-propelled field pieces, reflecting a deliberate move away from towed guns for those formations. The transition was not only technical, but organizational. The same historical source notes that the M108 was the initial self-propelled standard for armored and mechanized divisions in 1963, but within 2 years it began to be replaced by the M109 155mm self-propelled howitzer. That replacement helped standardize divisional artillery around a more capable self-propelled platform, and supported the Army's broader objective of artillery units that could reposition quickly and operate with greater dispersion. The M109 family evolved in clear engineering-driven steps. First the gun, then the platform's reliability and protection, and finally, the integration layer that determines how fast a battery can fight and move. The baseline M109 established the core architecture, a turreted, tracked 155mm system. The first major leap came with the M109 A, which introduced the longer 155mm gun, improving ballistic performance, while keeping the underlying platform concept intact. From there, the M109 A2 and M109 A3 concentrated on practical sustainment changes: reliability, availability, maintainability, and internal improvements, while the A3 largely functioned as a rebuild path to bring earlier vehicles closer to the improved standard. The M109 A4 added nuclear, biological, and chemical protection, and further reliability changes, reflecting a system expected to function in harsher operating environments. The M109 A5 is where the weapon system upgrade becomes explicit again. It introduced the M284 cannon paired with the M182 mount, improving the gun and its installation, without abandoning the proven turret and chassis approach. The M109 A6, known as Paladin, shifted the modernization center of gravity toward integration, fire control, navigation, and communications, because those subsystems drive responsiveness and crew workload, as much as the gun itself. Finally, the M109 A7 continues the Paladin integrated management path by modernizing the vehicle platform for higher readiness, while preserving the established artillery role inside armored brigade formations. Today, the M109 family is still in active service, with the United States Army transitioning its armored brigade combat teams from the Paladin generation toward the M109 A7. The Army publicly marked that shift by accepting the first M109 A7 system in April 2015, presenting it as a modernization track meant to keep pace with heavy maneuver formations. Outside the United States, the platform remains widespread. South Korea is one of the largest operators, with about 1,040 M109 A2 systems, produced under local co-production, forming the basis for the K-55 line. Israel is another major user. An Israel Defense Forces equipment listing gives 250 M109 Doher in service, while newer systems are being introduced to replace them over time. Beyond these two, the operator landscape remains broad across Europe and the Middle East. Open-source compilations that cite the International Institute for Strategic Studies list substantial fleets in countries such as Jordan and Egypt, and smaller but still operational fleets across several European users, depending on variant and modernization state. The M109 mattered because it did more than deliver shells. It locked artillery into the tempo of mechanized warfare and proved that a self-propelled howitzer could be treated as a long-lived system, an architecture designed to absorb change. Across its variants, you can see the arc clearly. Improved guns, then improved protection and reliability, then a shift toward integration. That turns the platform into a faster, more autonomous node in modern fire support. That evolution did not end with Paladin. In the M109 A7 era, it is still underway. Subscribe for more technical breakdowns of military systems, one platform at a time.